2 for digital communication. Now we're going to discuss some calculations, system calculations that involves in digital communication. So last time we discussed about different types of modulation, which includes their constellation, phasor, and truth table. So, and we find out that the digital modulation is just like an analog modulation. Galing lang siya sa analog modulation natin. And the principle that we're using in the analog modulation will be the same, pero ang kailangan lang natin ay we need to convert all analog information into a digital signal prior to modulation. Now, in modulation process, we need basically the truth table. So the truth table is the one that will tell us what kind of digital modulation involves in a system. And nakadepende din yung modulation na to sa number of bits na kailangan niya i-process. So meron tayong tinatawag na die bit or the 2-bit, we have the tri-bit or the 3 bits, we have the quad bit, and so on. And in in modulation, ang difference na, let's say for example, we have a phase shift modulation. The each data has a corresponding phase angle. No? The difference of Comm, the difference of the Comm to phase modulation is that it requires or it has a phase angle and amplitude. Wherein in Comm, it is considered to be a hybrid modulation where two signals or two data can have the same phase angle, but it can defines the other through their amplitude. So yun yung ating pinag-aralan ng nakaraan. So now we're going to move on the other topic, which is the calculation, no? System calculations for digital modulation. Okay, so we have for the introduction, modulation performs the greater role in transmission, and we all know that sinabi na natin ito. We have different forms like PSK, FSK, QQAM, and also the other types of modulation na i-discuss later on, no? Yung mga special types of modulation. Now, for the parameters, okay, ano-ano ba yung mga parameters na kinakalculate that defines the characteristics of the digital communication? So, meron tayong tinatawag na line speed and the minimum bandwidth consideration. So when you say the line speed, that is the speed of transmission of a system, no? So definitely, mas mabilis kapag maraming bits ang pinaprocess at the same time. So yun. Kaso kapag mataas or maraming bits ang kino-consider natin at the time, so mas complicated yung modulation technique na gagamitin. And then, kung complex yung circuitry na required, but you will attain a system that is faster. And also the minimum bandwidth, as we all know, that if you increase your speed, okay, if you increase your speed of transmission, definitely you need to have a more bandwidth allocation for that. Kasi yung speed ay directly proportional or yung bandwidth ay directly proportional to the speed of transmission. Mas mataas ang speed, mas mataas ang bandwidth requirement doon. So magkapatid yan. So the digital data parameters that includes line speed, minimum bandwidth capacity requirement, the MRE coding. So when you say MRE coding, that is the possible combination. And we have also the baud rate. So yung baud rate, ano yung ibig sabihin niya? So meron kasi tayong tinatawag na bit rate, okay? And meron din tayong tinatawag na baud rate. So anong difference between the two? Pag sinabi nating bit rate, so this is your modem, okay? Yung speed na pumapasok sa modem, that is referring to your bit rate or your throughput. Okay? While yung speed na binibigay ng modem mo, that will be your baud rate. Okay? Input bit rate. Yan tinatawag siya the input bit rate of the system. So may ganun, or the line speed of the system. Bit rate, yun. Tapos pag sinabi nating baud rate, so nakadepende itong baud rate mo sa klase ng modulation technique. So kung 16 QAM, 16 PSK, so nababago yun. Okay, so again, ang bitrate ay yung papasok na speed doon sa modem or tinatawag natin na line speed. Yung baud rate naman ay yung speed na binibigay ng iyong modem or sa output ng iyong modem. Ngayon, yung bitrate, minimeasure siya in terms of bits per second, pwede din kbps, kilobits per second, pwede din mbps, etc. No? So itong baud rate mo naman, pwede din siya sabihin na bits per second or equal din siya sa tinatawag natin na baud. Kaya pagka nakakita kayo ng baud, kilobaud, output yon, output ng modem mo. Pwede din naman siyang, let's say, kbps, that is equivalent to kilobaud, kbaud. Okay? And you have mbps, pwede din siyang i-designate as mbps or pwede din siyang megabaud. So, basta yung bitrate, ang tawag lang sa niya mga bits per second. Mbps, kbps. Pero pagka baud rate, pwede siyang tawagin na bits per second, kbps, mbps, or baud, kilobaud, or megabaud. So, basta nakakita kayo ng baud, ibig sabihin nun, that is taking at the output of your modem. Maliwanag? Susundan?
Di ba nandiyan yung parents sa class? Papunta niya dito.
Yes po, sir.
Okay. So, meron din tayong tinatawag na FA. So, ano yung FA? That is your analog frequency. And your FB, that will be your input bit rate. Or parang yan yung frequency of your bits. Actually, yours, parang ang ginawa lang yan kasi sa Nikis criterion, meron tayong tinatawag na the maximum analog frequency or the sample frequency is actually your FB, no? That is equals to twice your FA. Pagka kasi pinag-cross multiply mo yan, that will be FP is equals to your FS or sinatawag natin na sample frequency. And pag sinabi natin sample frequency, that is twice the analog frequency na given. So kung anong given mong frequency, you're going to multiply it by 2 only. So to determine your sample frequency or your FB na tinatawag. Then meron din tayo tinatawag na FN. Okay. Your Fn is twice of n times Fa. So ano yung n na to? So that is the number of bits. Kung mapapansin mo, parang FB lang, Fa lang siya. Okay, twice F. Parang FB lang actually, kasi 2Fa, no? Parang FB lang na multiply mo sa n, where n is the number of bits. So nakadepende yung n natin na yun kung dibit, quad bit, tribit, pentabit, etc. And yung FM na to, or your FS na to, is different sa tinatawag natin na to. So here, that is your sample frequency. Sample frequency yan. Itong FS na to, hindi yan yun, no? So ito ay tinatawag natin na mark and space frequency. So ano yung tinatawag na mark and space frequency? So since we are dealing with the digital signals, okay, meron tayong tinatawag na 1, 0, 1, 0. So pag sinabi natin 1, that will be your mark frequency. Pag sinabi natin 0, that will be your space frequency or yung mababa. So since kung pag-usapan natin ay yung magkamukhang duty cycle, so ibig sabihin magkapantay yung ating pulse width or your pulse width is half of your total period, we can say that your mark frequency will be the same as to your space frequency. And therefore, that is equals to n multiplied by FB over 2. Eh, ano ba yung FB over 2? So that will be your FA. So you're going to multiply n into an FA to get your mark and space frequency. Then meron din natin tinatawag na BE. Ano yung BE? So that is FB multiplied by FN. So that is called, BE is your bandwidth efficiency, no? So bandwidth efficiency. Ano yung bandwidth efficiency? So the bandwidth efficiency is the utilization of your bandwidth depending upon doon sa coding levels natin. Later malalaman niyo kung ano ibig sabihin nun. And nakadepende din ito sa klase ng modulation technique. So the bandwidth efficiency depends on the modulation technique na ginagamit natin. Okay. And ito pa another formula natin, that will be the m is equals to 2 raised to n, or n is equals to log of n to the base 2. Actually, your m here is your memory coding. So your M is for Emory coding or yung tinatawag natin na mga possible outcomes o output combination. Pag sinabi nating 32 QAM, so there are 32 possible combination. Yan ibig sabihin ng Emory. Okay, so yung mga formula natin na yan, kailangan yung tandaan. Okay. Okay, so where sinasabi doon, yung Fs is your space frequency. Your Fm will be your mark frequency. Your Fp will be your input bit rate or yung ano tawag dito, input bit rate to. Bit rate yon or the line speed. So equivalent din ito sa line speed natin sinasabi. Fa is the modulating or the fundamental frequency. Okay. Then yung related to that will be the sample frequency, the analog or twice the fundamental frequency. And M is the Emory coding or the number of possible output. So kaya pag nakakita kayo ng 64 QAM, understood that is 64 possible combination. 32 QAM, understood that is 32 possible combinations. So yung N na maliit, yun yung tinatawag natin na the number of significant sidebands. So do you remember in FM, di ba? So the number of significant sidebands matters doon sa determination ng bandwidth natin. And the N na malaki will be the number of bits. So ito yung, kaso sa may formula natin, di ba, 2 raised to N. So yung N na yon, ito din yung N na dito. Parang nakakalito lang, no? Pero here, specifically, yung N na maliit is for significant sidebands. Yung N na to, yung sa formula natin na to, is actually 2 raised to N. Yung N yung tinatawag na equivalent sa M or sa Emory encoding. And Fn, pag sinabi natin Fn, is the minimum required bandwidth or tinatawag natin na minimum nearest bandwidth. Okay? So, pag sinabi natin minimum bandwidth, ano yung bandwidth requirement ko kapag ganito yung speed ng line? Parang ganun siya. So, kasi halimbawa, mabilis siya, pero hindi naman kaya ng bandwidth. So, ano sinabi natin kanina? That the bandwidth requirement depends on the bit rate or the line speed mo. Kung mataas ang line speed mo, you should expect that bandwidth requirement is also high. Okay, so ganon. And BE, as I've said, is the bandwidth efficiency or the utilization of the bandwidth, which is dependent on the types of modulation. Ngayon, yung bandwidth efficiency, mas maganda kapag tumataas ang Emory coding. O ibig sabihin, tumataas yung number of bits na pinaprocess. Okay, so yun yung mga parameters or epekto ng parameters na to sa mga formulas. So let us discuss bit rate and baud rate. Pag sinabi nating bit rate, sinabi ko na yon kanina, introduction. Pag sinabi nating bit rate or FB, FB kanina is your line speed din, no? Is also called your line speed, which is measured at the input of the modem. Unit is expressed in bps or the bits per second, kbps or the kilobits per second, mbps or megabits per second, pwede din gbps. While baud rate is the line speed measured at the output of your modem. Units expressed in bps or baud, kbps or kilobaud, mbps or megabaud. So pwede din siyang tawagin siyang kbps, bps, mbps. So pwede siyang tawagin both. Pero sa bitrate natin, ito lang yung mga units na pwede sa kanya. Nagets? Nasundan? O medyo naguguluhan? Do you have question?
Okay pa naman po, sir. Wala pa naman
Okay.
po.
So below is the summary of the different parameters of digital modem. No? Ito yung mga parameters. Summary. Okay. Yan. So, ito yung mga different modulation technique. Do you agree? Di ba meron tayong pinag-aralan ng IPSK or phase shift keying? Then, pag walang nakalagay yan, it is understood to be a 2PSK. Okay, 2PSK yan. Di ba sabi natin that 2PSK is the same as FSK, is the same as BPSK. Di ba yung nakaraan natin? Yan yung sinabi natin. So actually, yung dalawa na to, equal lang yan. Okay? Kung mapapasin mo, the number of bits, so this is your N na sinasabi natin kanina, yung formula natin. Yung N na malaki dyan. N. Pag 2PSK, that is 1 bit. Pag BPSK, that is 1 bit din. As yung formula natin dyan, 2 raised to N, di ba? So that will be if N is 1, so the possible combination will be 2. Kaya sa sinawag na 2PSK or BPSK, which is binary phase shift keying. Ngayon, ang bandwidth mo, FB. Yung bandwidth ko din, FB. Kaso, ang unit nito, naka-FD siya, ang unit nito ay hertz or megahertz. Depende yan kung nakano. Kung mapapansin nyo, yung bandwidth ko will be the same as your baud rate. Okay? Baud rate. Napansin nyo ba? Kahit anong modulation technique yan, natin na FB is equals to FB, FB is equals to FB, FB over 2, FB over 3, FB over 3, FB over 4, etc. Nakita? Kaya pala, pag nakita mo, yung baud rate mo, nakuha mo na, makukuha mo na yung tinatawag natin na bandwidth. O ito tinatawag natin na minimum bandwidth. So pagka nakuha mo na yung baud rate mo, which is dependent on the types of modulation, you will get the bandwidth na. Kaso ang unit ng baud rate mo, pwedeng BPS or bauds or kilobauds, kbps. Diba? Sundan. Then, kung mapapansin nyo din, yung number of bits will be the same as your bandwidth efficiency. 1, 1, 2, 2, 3, 3, 4, 4, 5, 4, 4, 3, 3, 4, 4, 4, 4. So, mapapansin nyo, yun yung relationship niya. So, the number of bits is actually your bandwidth efficiency. The bandwidth or the minimum bandwidth or the next bandwidth will be the same as your baud rate. Kaso, ang unit ng baud rate magkaiba sa bandwidth. Kasi ang unit ng bandwidth ay hertz or megahertz. Ang unit ng baud rate ay bps or bauds. Nagets? So, yan yung ano natin. So, saan nakadepende itong number of bits? Sa MRE din. So, ito yung tinatawag natin na MRE. Yan. Yan yung tinatawag natin na mga MRE coding or the number of possible combination. Sundan. Kaya madali lang. Ngayon, sir, anong pagkakaiba ng 16 PSK sa 64? Actually, wala. Papapasin mo, 4 na bits, which is 16 possible combination. Ang bandwidth efficiency ko is actually, FB over N. FB over N. Since N here is, malaking N. Tingnan mo nito. FB over N. Kung halimbawa, welcome 4 bits. So, binigay ang input bit rate mo. Divide mo lang ng 4, makukuha mo ni bandwidth, but make sure your unit is in hertz. Ang baud rate, sinabi natin, baud rate is equals to FB over N din. So FB is your input bit rate, your N is the number of bits na ipaprocess mo. So kaya very similar yung dalawa na to, and the bandwidth efficiency will be the same. Okay? Sundan? Actually, the bandwidth efficiency, kung formula natin, bandwidth efficiency, sabi natin doon, FB over baud rate yan. Palagi yan. FB over baud rate. Kung mapapasin mo to, halimbawa, ito tingnan natin, no? Yan, no? Yan, tingnan natin. So, the bandwidth efficiency niyan will be FB, constant yung FB, over FB. FB over 1 bit. So, the answer is FB over FB. So, the answer is 1. Kaya nakuha yun. Ngayon, kung halimbawa, kukunin ko itong QPSK, so the bandwidth efficiency of QPSK will be FB is constant. Ano yung QPSK? That is dalawa yung possible combination. So, that will be FB over 2. So, cancel yung FB, yung 2 mapupunta sa taas. So, the answer will be 2. So, kaya nakukuha yung 2 na yun. And so on and so forth. Nagets? So, yan lang yung kailangan, yung formula na kailangan in order for you to calculate some of the digital modulation technique. Okay, another. Meron din tayong tinatawag na probability of error at saka bit error rate. So, what is the difference between the two? So, when we say probability of error, it is a theoretical or mathematical expectation of the bit error rate of a given system. Pag sinabi nating bit error rate naman, that is the historical or the empirical data of the system of the bit error performance. Ano ibig sabihin, sir, ng historical at theoretical? Pag sinabi nating probability of error or PE, yun yung calculation na ginawa mo. Okay? Calculation mo, kinalculate mo na. Pero yung actual na error na naganap, that is called your bit error rate. Again, ang difference between the two is that yung probability of error, yun yung calculation na ginawa mo sa system, you are forecasting the error, pero the actual error that will occur is referred to your bit error rate. Sundan. So, pero similar yung dalawa na yan, pero ito, actual yung sukat. Ito, yung theoretical lang kasi yun yung calculation mo. Sundan? Ngayon, ano ibig sabihin ng bit error rate? So, since we're going to transmit series of data, 1, 0, 1, 0, 1, 0, di ba ganyan? Nagsisend tayo niyan halimbawa ng data. Kasi 1, 0, 1, 0, 1, 0, 1, 0. Eh, hindi lang naman 10 itatransmit natin. Kung meron tayong 10 Mbps, so 10 bits ang itatransmit natin sa isang segundo. Is a series of bits. Ngayon, pag halimbawang merong na ano dyan, nawala, nagkakaroon ng error yan. Agree? So, doon na pumapasok yung tinatawag natin na error rate. So, that is dependent kung yun ay probability of error or bit error rate. Ngayon, another question. Ano ang mas maganda? Ang bit error rate that is 10 to the negative 10 or the bit error rate that is 10 to the negative 12? Ano ang mas magandang system dyan? Bit error rate that is 10 to the negative 10 or bit error rate that is 10 to the negative 12? Anyone? Mr. Hermosa? So palagay mo, kung I have a bit error rate of the system that is 10 to the negative 10 and the bit error rate that is 10 to the negative 12. So yun. Nilalag na si Hermosa. So that's correct. 10 to the negative 12, mas maganda. Why? Bakit? Mr. Pinesa. Ang sabi ni James, parang noise ratio lang. Okay, so that's correct. Mr. Pinesa, what is your thought? So the answer of 10 to the negative 12 is correct. So, but why? Yes.
Pero ulit nga po ng tanong.
Okay, so meron tayong system na bit error rate that is 10 to the negative 10 at bit error rate that is 10 to the negative 12. My question is, ano yung system na mas maganda dyan? So tinanong ko sa Hermosa, ang sabi niya 10 to negative 12 as supported by Mr. Acuña, which is correct. But the question is, why do you say so that if you have the bit error rate of 10 to negative 12, that would be more reliable if you have the bit error rate of 10 to negative 12?
Sir, siguro po yung may epekto po ba dyan yung bandwidth, sir?
So, okay. So, paano yung bandwidth?
Mas malaki po yung sa 10 negative 12 po.
Okay. So, ganito yung analogy class, no? Pag sinabi nating bit error rate that is 10 to the negative 12 at saka 10 to the negative 10. So, ibig sabihin nito, magkakaroon ka ng isang error on the data transmission that is 10 to the negative 12. Di ba? Parang ganun yan. Then magkakaroon ka ng isang bit error if you have 10 to the negative 10 to the 10 na bits. So, ibig sabihin nun, ganito karami ang data ko na itatransmit para ako magkaroon ng error na isang bit. Tapos, ganitong data na itatransmit ko para magkaroon ng isang error na bit. So, may ibig sabihin, mas mataas na data na exponent dito, yun yung mas maganda kasi mas less yung error ibig sabihin nun. So, ang tanong kasi, anong system ang maganda? Natural, yung may system na mas maliit ang error. Kaya yung bit error rate na to, okay, in terms siya ng accuracy. Mas mababa ang value niyan, mas maganda yung accuracy. Okay? Kaya pagka tumingin kayo ng mga digital system, makikita nyo din itong bit error rate as parameter. So kung kayo tatanungin, piliin nyo yung mas maliit ang value, which is 10 to the negative 12. Okay? So nakuha? Nasundan ba? So yun. Sige. Alam sumagot. Let's have a sample problem. Ito na yung mga calculation. Ito madali lang calculation na to. A digital modem process tri-bit data at a time. What is the Emory coding? Pag sinabi natin tri-bit, that will be n is equals to 3. Tama ba? Ano ba yung Emory coding? Emory is equals to 2 raised to n sa formula natin. So that will be 2 raised to 3. So the answer is 8. Ayun yung sagot. Gets? Nasundan?
Opo, sir.
Yun lang ha. So nasa formula lang yon. Yung Emory is a number of possible combination. Okay? So let's continue. Problem number 2. Okay, problem number 2. Yan. So the digital modem has an input bit rate of 200 kbps. Pag sinabi natin input bit rate, ano yan? That will be your FB. If the baud rate is 100 kbps, what is the minimum bandwidth of the system? So ano daw ito? Baud rate. Sabi natin kanina, baud rate is equals to your Fn. Tama ba? Hoy, di ba sabi natin, yung minimum bandwidth nakadepende saan? Sa baud rate. So kahit ano pa yung ginagawa ni bit rate, ang titingnan lang natin ay yung baud rate. So since sinabi baud rate is equal sa bit rate, sa Fn, sa formula natin, therefore the minimum bandwidth will be 100 kilohertz. Gagawin mo lang hertz itong bits per second mo kasi sabi natin, yun lang ang difference ng ating baud rate sa input sa ating minimum bandwidth. Okay? Kaya ibig sabihin nun, pagka meron kang system at hinahanap ang minimum bandwidth, tingnan mo agad ang baud rate, then palitan mo ang unit ng baud rate ng hertz lang ang dulo. So, yun yung difference nila. Magkamukha siya ng value, but iba lang ang unit. Pag baud rate, kbps or kilovolts, pagka bit rate ng minimum bandwidth, kilohertz, megahertz, gigahertz, etc. Nagets? Eh sir, anong kinalaman ng 200 na to? Wala. Kasi input bit rate yan ang after tayo sa baud rate. So kasi ang itanatanong natin ay minimum bandwidth or your Fn. So that would be the question. And sabi natin that the Fn is the same as the baud rate with different units. Gagawin mo lang hertz yung unit ng baud rate. Gets? Kaya naging 100 kilohertz siya. Nasundan? Nasundan?
Opo,
Yes
sir.
po, yes po.
Yes. Next. Meron tayong 16 PSK modem and has a baud rate of 100 Mbps. What is the bit rate and what is the minimum bandwidth? O, kita-kita natin, 100 Mbps. At alam natin, yung Fn mo is the same as the baud rate, di ba? So that is equals to 100 megahertz, megabits per second. Ano gagawin? Megahertz. So yun yung sagot natin. Eh ano pa tinatanong? Bit rate. Sabi natin kanina, baud rate is the same as bit rate over n. Okay? Bit rate over n. Eh, since 16 PSK yan, sabi natin, the 16 PSK is the Emory coding. So, ilan yung n mo dyan? M is equals to 2 raised to n. So, therefore, if ito ay 16, actually, that is 2 raised to 4. So, ito yung ating n. N here is equals to 4. Ngayon, if you have here a bit rate, a baud rate, baud rate ang binigay, 100 kbps. So, pwede mo sabihin your FB is equals to N times baud rate. So, that is equals to 4, yung input bit rate mo from the Emory coding, multiplied mo sa baud rate of 100 Mbps. Okay. So, the answer is equals to 400 Mbps. Always remember that your FB note, palagi yan ha, your FB or the input bit rate must be greater than or equals to your baud rate. Posibleng mag-equal ang bit rate sa baud rate pero palaging mas malaki ang input bit rate kaysa sa baud rate. Kailan magaganap na yung FB mo is equals to bit rate? When your N is equals to 1. Eh kailan yun? Kapag ka ang modulation technique mo ay 2PSK, BPSK, or FSK lang. Nagets? Nasundan? Again, yung note na to, your input bit rate is greater than or equal to baud rate. Palaging mas mataas ang input bit rate kesa sa baud rate. The question, kailan posibleng magkamuka ang bitrate mo sa baud rate. Magiging posible lang that FB is equals to baud rate if the modulation techniques are 2PSK or BPSK or FSK. Yun lang. Other than that, this equation will be true that FB is greater than baud rate. Sundan. Sundan yon.
Yes po.
Okay. Next. Okay. So number 4, a 32 QAM modem has a line speed of 200 Mbps. Calculate the following. So ano yung ating 200 Mbps na to? Line speed. Therefore, ito ay ating FB. Then tinatanong dito, number of bits transmitted at a time. So ilang bits to na-transmit at a time. And since binigay ang 32 QAM, so alam natin that the MRE is equals to 32. And alam natin that is equals to M is equals to 2 raised to N. So 32 yan, 2 raised to ilan ito? So usually it is a 5. Therefore, N here is 5. Okay? 5 yan. Ano yung baud rate? So sabi natin, baud rate is equals to input bit rate over the N. So since sabi natin that is 5 from the MRE coding, so you have 200 Mbps all over mo ng 5. So the answer will be 40 Mbps or 40 megabaud. Okay? So that is the answer. Yan. That's the answer. And 5 is the answer. And we have also the minimum bandwidth. Ang minimum bandwidth natin, sabi natin that bandwidth, Fn is the same as to your baud rate with different units. Therefore, your minimum bandwidth is equals to 40 megahertz. So, papalitan mo lang unit ng BPS ng hertz since the unit here is 40 megabits per second. So, the answer now for your minimum bandwidth will be 40 megahertz. Okay? Nasundan? Nasundan yun?
Yes po.
Tinahanap din yung MRE coding. So, sinabi natin, MRE coding M, kitang-kita mo na 32 QAM. Yung prefixes mo dito, the unit, that will be your number of possible combination. Therefore, 32 is the answer. Kaya, unit natin yan, 5 bits, 40 Mbps, 40 megahertz, and 32. Okay? Kaya madali lang yung ating calculation dyan. Okay. Number 5. If a certain system has a 2 bits RAB in transmitting 2 times 10 to the 12 bits, baba natin yung bits dyan. Gawin natin dito, bits of data, solve for the following. Ibig sabihin nun, meron daw system na nawawala ng 2 bit every time na mutatransmit siya ng 2 times 10 to the 12 bits of data. So ano yung bit error rate? Ibig sabihin nun, ang bit error rate ko, letter A, bare, ilang bits ang nawawala? 2. Ilan yung tatransmit ko? 2 times 10 to the 12. So, yun yung bit error rate ko. Kaya, the answer will be 10 to the negative 12 ang answer. Or 2 all over 2 times 10 to the 12. Or, pwede natin sabihin ito na 10 to the negative 12 ang bit error rate. Okay? Then, pangalawa, what is the total bits of having no error? Since yung nag-transmit ako ng data ko, letter B, 2 times 10 to the 12. Yan yung buong data ko. And nagkaroon ng error. Ilang error? 2. So that will be the answer. So that is 2 times 10 to the 12 minus 2 bits. Hindi ibig sabihin na 0 times 10 to the 12. Hindi pwede yun. Dito ka babawas ng 0. Kaya almost the same lang din yan na roughly 1.9999 times 10 to the 12 din yun. Almost the same. Okay? So, kaya yung sagot natin here will be 2 all over 2 times 10 to the 12. And letter B will be 2 times 10 to the 12 minus 2 bits. That is the bits that has no error. For the summary, live application, and biblical implications. So, digital modulation techniques like FSK, PSK, and QAM has various parameters, which includes minimum bandwidth. So, ang minimum bandwidth natin nakukuha sa baud rate. Papalitan mo lang ang unit. Line speed, actually the line of your, the input speed at the modem. The bit rate will be the same as your line speed. The baud rate, that will be the output rate of your modem. The bandwidth efficiency is actually your number of bits taken, or you have a bit rate all over baud rate. And BER, the bit error rate, which is, it is defined as the actual error that will occur on the system. The probability of error is actually the calculated value of your error. So these parameters are used to interpret the performance of the digital system. So yung lahat na yan, makikita nyo yan sa isang digital device. So if you're going to look on the specifications, so you will find those parameters. And yung mga sinabi ko sa inyo, yun yung pagbabasa ninyo kung mas maganda siya o hindi. Okay, so life's application and thoughts to ponder. Digital communication may experience errors during processing, transmission, and reception. These errors affects the system performance and reliability. In life, all of us commit sins. It is a form of errors that affects our beings, our relationship to God. We need to fix it and repent for it for us to become eligible in God's reception. So that's all. And thank you for joining this session. So if you have any more question, kindly raise it now. So the floor is open for any queries with regards to the discussion. Any question? Okay, open na nga inyong camera. Any question? Intindihan ba, Mr. Quinones?
Okay naman po, sir.
Sakto lang.
Opo, sir.
How about you, Mr. Omali?
Okay naman po, sir.
Wala kayong tanong?
Sir, asa po ba kayo ngayon, sir?
Palagay mo.
Opo, sir.
Andito ako. Bakit? Nagdadrive ka ba?
Opo,
Ay,
sir.
Huwag ka nang manahimik ka. Huwag ka munang mag-drive ka muna bago ka magsalita. Baka magka-ano ka pa dyan. Madria, tumatawa ka, Madria. Tawanan mo si Quinones. Madria, may tanong ka ba,
Sir,
Madria?
papunta po kasi kami Muslim.
Ano ba gagawin mo dito, Quinones?
Sir, may lab daw po eh. Sa sa isa po. Pag di sa Spectra po.
Akala ko sa akin.
Opo. Tapos magte-take din po ako sa inyo, sir.
Ay, uulit ka din. Kung hindi ka prepare, uulit ka ulit. Kung hindi prepare, wag na pumunta sa hindi pamasahe, ha? Okay.
Sir, isang punta naman na, sir. Sayang naman.
Okay, sige. So, did you browse your canvas? So, your laboratory simulation is already uploaded. So, you're going to pass it on Saturday and on Sunday. So, that is a multi-sim simulation. It is a group activity. So, ibig sabihin, yung isasubmit mo doon ay yung kung ano yung isasubmit ng group. No? So, pero yung group leader, isasubmit sa akin yung output sa akin. Pero individually, maglalagay kayo doon para magkaroon ng laman yung canvas nyo doon. Kung ano yung sinabit ng group leader, yun din yung isasubmit nyo doon sa canvas nyo. Kaya group activity yun. So basically, baka leader lang din ang gumawa. Okay lang. Simulation yan. Pero pagka nag-actual yun, i-actual yun dito yun. Okay? So, all the group leaders, we're going to send the group activity sa akin. Individually, you're going to upload your group output sa individual Canvas account. Okay? So, that would be up to Saturday and Sunday, I think. Okay, Miss Airoso, you have a question?
Wala naman po.
Miss Andrea, you have a question?
Wala po.
Itong pag magtanong. Pastor, you have a question? Tanong sa paso. Ngayon, magtanong ka. Pastor Beans. Dalawa pala yung pastor dito. Wala. Okay, so wala nang tanong. So kung wala nang tanong, so I think you will be having your quiz next meeting. Pagka nagpunta kayo dito sa lab, so you'll be having your quizzes. Para isang puntahan na lang kayo. So siguro wala muna tayong prelim kasi magmi-midterm lang tayo tsaka finals. Okay? Pero you will be having your quiz once you go here for your laboratory. Maybe it is 20 minutes quiz. So isang subjects, 30 to 40 minutes para sa dalawang subjects niya. Comm 2 and logic. Okay? So I will announce it next week kung kailan kayo pupunta. But definitely next week, not this week. Kasi tomorrow wala na naman kami. We're going to Baguio. So Friday lang ako nandito. But I have a schedule in 4th year sa Friday. Kaya makikita ko kayo next week. Okay? Wala nang tanong. So wala nang tanong, Mr. Pinesa, kindly take the attendance.
Okay po, sir. Now, up and cam na. Okay. 1, 2, 3. Isa pa po, sir.
Okay.
1, 2, 3. Okay na po, sir. Thank you po.
Okay. Thank you very